Thanks for joining us. Thank you, everyone. This is our fourth Brown Bag Lunchtime webinar. This is Mark Dempsey with the National Convergence Technology Center here at Collin College in North Texas. With us today is Kerry Bruce. He is a CIS instructor at Central New Mexico Community College, where he teaches CompTIA, Cisco, and Microsoft classes. He founded the school's Hackerspace program to encourage hands-on technology learning. He's obviously a big proponent of using Raspberry Pi in CIS classes, including middle schools and high schools. And he conducts a number of Raspberry Pi workshops and presentations each year. Prior to teaching, Kerry spent many years in the IT industry, serving both as frontline administrators and analysts, and also as higher level directors and partners. He also started a very cool website to provide resources for IT faculty called myitinstructor.com, so you definitely want to check that out. All right, so thank you for your time today, Kerry. I'm going to hand off to you now. I'm going to stop sharing my screen so you can take over.
All right, welcome. So integrating the Raspberry Pi into your CIS program. So like I said before, like it was mentioned before, I am a big proponent of the Raspberry Pi. And we'll kind of go through that today. We're going to fly through a bunch of stuff, probably at 30,000 feet. But you will find I have a web page put up for you that will actually allow you to dig down to ground level. And you can spend years going through the stuff that we're about to talk about in the next 20 minutes. So yeah, so I'm hoping that you enjoy, and we'll go from there. I will point out that the background screen that I'm using today is actually a picture taken from a Raspberry Pi attached to a balloon at 40,000 meters high above the Earth. So pretty cool stuff. All right, I'm going to move this bar out of the way here. So get a little bit kind of where I come from. This is probably one of my favorite quotes as far as dealing with education. I've been impressed with the urgency of doing. Knowing is not enough. We must apply. Being willing is not enough. We must do. And I share this with my students at the beginning of every semester so they understand kind of where I'm coming from. I want to see you do stuff. You know, knowing some things is great, but if you can't do it, you know, I'm not impressed, right? And then being willing is not enough. And I know as instructors, you probably have like, you know, give me a second chance, give me a third chance, give me a fourth chance. You know, yeah, you're willing, but if you're not going to do it, then right, that's a big thing for me. So I'm a real big proponent of hands-on. And you'll see by using the Raspberry Pi, there's lots of opportunities for hands-on. I also use, we use VMware, like a Nutanix system for servers. And so I have my students doing hands-on across the board, but the Raspberry Pi allows a lot of that to happen. So just so you get a sense of kind of where I come from, I'm a really big on the do. It's a big piece of how I approach things. So what I want you to get from today, this 20-minute talk real quick, is to look at your curriculum and look at your classes that you teach. And, you know, as we go through, is there some place where you could maybe switch out a project or an assignment and have it done on a Raspberry Pi instead of maybe on an online lab, or maybe you don't have a lab for something and you could use a Raspberry Pi to do that. And to enhance, you know, your students' engagement. I think really when they start to get, and when they're touching things and plugging things in and having to make things work, there's a lot more connectivity happening there. And I really think it's critical in teaching IT and CIS. Right, so we do have an agenda. So we'll talk about why the Raspberry Pi. We'll talk about 90% of what we're going to talk about today is kind of the potential uses. We are not going to cover number 3. Otherwise, we'd have to be here for an hour, right? So that's another half an hour worth of talk. So, but I did leave the slides in there at the very end of the presentation after the conclusion. And then at the end, we'll do, you know, hopefully we'll have some time for questions and I can answer whatever I can. And then if not, I will have my email later on, and you can certainly email me at any point, understanding that this is the last week of the semester. So I'm grading the next 2 days, and then I'm literally taking 17 days off, and I'm not touching anything for 17 days. So, so it'll be a couple weeks before I get back to you. The website that's here, I throw this up today. So that you can, in fact, I'm going to go back to the presentation. We'll get to that in a second because it's on the next page. This is a resource heavy presentation, right? So like I said, we're going to fly really high, but there's a lot of stuff to dig into. That link there will provide you the access to all of the links that I'm talking about. So obviously I want you to go out and check that out. And now I can show you what's going on. So this page here, so everything that we're going to talk about, so even the presentation is right here, so you can download the presentation. And then I have links on every, just everything I'm going to talk about. There's a link and digs into articles or tutorials or resources, tons of really good information in the background to what we're talking about today, right? So why the Raspberry Pi? So if you're not familiar with Raspberry Pi, it's the computer that you see there on the right-hand side of the screen. It is a credit card sized computer, and it costs $35, right? The base unit is $35. There are some newer units that are $55 and $75. But the cost is the biggest thing for me. One of the things I wanted to, as a community college instructor, is I want my students to be able to afford what we're doing. So I'm not saying, hey, go buy an $800 laptop or $1,000 laptop so you can do these labs. I'm looking at this going, well, spend $100, pick up a used monitor at Goodwill or a garage sale, get a keyboard, and in the same kind of way, and connect them together and start learning using this $35 computer. So the cost is a big factor for me. I really, take into consideration that I am dealing with community college students and I want to keep their costs low. I look at it from the perspective as well that the cost of this, the computer and the parts and pieces is maybe 2 video games worth, right? So, right, because that's our students, right? Maybe 2 video games worth, and it has a whole lot more content than 2 video games, right? A video game, if a student sat down and played it for, all their extra time, they're done with it in 4 to 6 weeks. I can give them 4 years worth of material that they can learn using a Raspberry Pi. So kind of that trade-off. And I've always had these conversations with my students about, the trade-off of paying an extra $100 to take an exam again in order to get a $2 raise, right? And what does that look like? So from that standpoint, the cost is a big deal. The flexibility, expandability of this unit, it's got USB, it's got Ethernet, it's got Wi-Fi, it's got the GPIO pins, which are these little guys right here, which allows me to connect all kinds of sensors and arrays and all kinds of other things that I can connect to this, and I can build things, I can make things, I can be creative with a computer in the physical world. And in addition to that, these pins allow me to also plug in what's called a HAT, a hardware attachment on top. And these are pre-done circuit boards that add functionality like battery backup or LED panels or let's see, I'm trying to draw a blank right off the bat. That's really not good. But like I can add GPS, I can add cellular connectivity, I can add all kinds of fun things. Pretty low cost in most cases. And relays, like, so if you wanted to do Christmas light display, I can put relays on this and actually control Christmas lights and things like that with the unit. The power and the size, tiny, right? I can fit it into a little bag. I can put it in my backpack. I can take it to school. I can plug it into a monitor. I can do lots of things with it. I can put it back in the box and put it back in my backpack and take off with it. And it's powerful enough, the new version, the Raspberry Pi 4, is powerful enough to be a desktop computer for most students at this point. It runs a Linux operating system. It can run 1080p. It can run multiple monitors. Actually, the new one can run 4K on 2 monitors at the $35 price point. Another thing that's really cool about the Raspberry Pi is the community. There is a humongous community around the Raspberry Pi. You can search in any search engine, Raspberry Pi and artificial intelligence, and you will find hundreds of articles about running artificial intelligence on a Raspberry Pi, or Raspberry Pi and networking, or Raspberry Pi and virtualization. And there will be somebody that has shared a tutorial, their code, they've got contact information. Everybody that I've ever reached out to is more than happy to just respond back and participate and help, right? So there's lots of support out there if you find yourself going down a path that you're not 100% familiar with, right? And the last piece on this is tactile learning. That goes back to that whole idea of doing, right? I'm touching things, I'm plugging things in. It kind of this has always taken me back to where I started to learn. I learned on a Commodore VIC-20, Commodore 64, TRS-80, those types of computers where you had to actually program things in order to make the computer do stuff. And We've lost that nowadays with normal computers because you basically unbox it, you plug the purple cable here, the blue cable here, the green cable there, and you turn it on. And there's not a lot of, what actually is happening. So the Raspberry brings you back to where you can do those kind of things, right? So the idea, the big part of what I wanted to go over is just in different classes that you have, right? There's different ways to use the Raspberry Pi. So for example, system administration, which is kind of my bread and butter, kind of where I sit. I'm a generalist. I do lots of things. In fact, I can teach almost our entire curriculum, but this is where I gravitate to. So the Raspberry Pi is based on Linux. It has a Linux operating system. There's actually 50 different distros that are available for it. Some are specialized, some are not specialized. So you have lots of opportunities to kind of explore things, try new things out, and play with it. Remote administration, you can teach students how VNC works, how SSH works, how KVM works, and you can show them the advantages of remote connectivity and remote administration. You can build any type of server that you can run on a Linux machine, which is pretty much every server that's possible, short of Exchange, right? So I'm not worried about that one, but we can do email, so that's possible. So you can actually build any type of server that you want to on a Raspberry Pi. You can teach network configuration, infrastructure. You can do network monitoring. You can teach how to do OS image flashing, right? So the idea of I've got to put out a bunch of, I need to have the same operating system, right? So I create an operating system, and then I image that operating system, and then I deploy that multiple times. You can teach virtualization. ESXi, actually, there's a version that runs on the Raspberry Pi. So you can actually use the Raspberry Pi as thin clients. So that's another thing that you can teach in the system admin world. We can, security-wise, we can run Kali Linux, so we can use that as a pen testing tool as a system administrator. You can teach system updates and package management on the Raspberry Pi. And then lastly, Wi-Fi, Bluetooth, Ethernet, those are all things that are on the Raspberry Pi that need configuration, right? And you can do some testing, and you can do some experimentation, and you can try to make things function that maybe shouldn't be functioning, but you can always stretch the boundaries there. So there's lots of learning opportunities in the system admin world. In the networking side of the house, like I teach a Network Plus course. So we have curriculum, we use Cengage. In my class, I'm the only instructor that teaches it this way. I have them do the curriculum on their own at home. But in the classroom, I bring in a box, literally a box full of Raspberry Pis. And we discuss, at the very beginning, what does a network need? And we kind of talk through all the processes of a network, and we do IP address planning and documentation. And then we break up into teams, and the students build that second bullet point. They build DNS, DHCP, they build wireless access points using a Raspberry Pi. The Raspberry Pi becomes a wireless access point. We build firewalls, we build proxies, we build file servers, print servers. We set up VPN. Twice we've attempted voice over IP, and we got really, really close. We haven't been successful yet, but we got really, really close. And those students learned a ton of material about how these things work. But you can see there's all these great things that you can do. So the other thing that I like about this class is we actually fire up Spiceworks, which is an online ticketing system. And we assign things through the ticketing system, so they actually learn how the real world works, right? So this is the ticketing system. We need documentation, and I need to, as you do things, you document what's going on, and their grade becomes how well they document it, and does the actual network work the way it's supposed to work. Usually we're done a couple of weeks ahead of time before the end of the semester, and the optional button is where they really want us to, where they're trying to get to, where they can build on top of the network that they've done. Let's maybe build some pirate boxes or do an own cloud setup, or in most cases we end up firing up Quake and playing multiplayer video game. To me, that's the reward for building a solid functioning network for this particular class. So there's lots of options you can do there, but it's really a fun. I got an echo there. Sorry. It's really a fun way to show them that once you have a solid infrastructure, then what you do with that infrastructure is kind of up to your imagination. Also, then in cloud computing, I don't have a timer anywhere, so we're good. We're good. Okay. Cloud computing. So we have cloud computing classes. I also teach IoT courses, and there's lots of bleed over between those two. But all the three big cloud service providers, AWS, Azure, GCP, all have an IoT infrastructure that you can connect Raspberry Pis to. In my IoT class, we use MongoDB, IFTTT. We connect Raspberry Pis to Twitter. We use a product called Dweet.io. You could set up Google AIY and do voice and vision. So you're actually, you press a button and you ask, okay, Google, and then it actually does everything. And that's based on a Raspberry Pi. Media centers. There's Hologram, Upswift, and Initial State are all kind of online monitoring solutions that you can actually take sensor data off of a Raspberry Pi and then post them on these really cool dashboards that you can build online. I've had students actually, we do an assignment on Initial State where they actually are pulling the 4 processors, the network information, the temperature and things like that. So they're actually pulling machine statistics right off the Raspberry Pi and posting those on charts on a web page. There's a company out there called Mythic Beast, and you can actually rent Raspberry Pi servers on the cloud. Right? So there's some pretty cool stuff you can do there. If you want to get into like the serverless architecture, you can start doing Docker and Kubernetes on the Raspberry Pi now. If you want to move into maybe more of the home automation world, there's a Home Assistant. There's another one, can't remember the other name, but there's a second product that they both have. They can use the Raspberry Pi as the base unit, and you can connect all your smart home devices to that and control that. So there's lots of really fun things that you can do there. You can actually make an Amazon Alexa out of a Raspberry Pi as well. So there's lots of opportunities for you to interact with cloud and specifically cloud service providers, but then lots of different providers online where you can share information or transmit information or move information from one system to another and control things from that standpoint. We can tie all of this back into, say, system administration, where in my IoT class, quite frequently we have students that build a environmental monitoring system for a server room, and then they connect that to, say, IFTTT, which then will alert them if any of the parameters, humidity, temperature, get out of line. So then they're actually building a device that helps them administer their network better using a Raspberry Pi. Instead of buying, say, a $500 system that'll do that, they build it for less than 100, and they've done it themselves and they control what's going on. So some fun stuff that you can do there. From the cybersecurity standpoint, Cisco does have a really cool IoT fundamental security course. I really enjoy that course because it actually takes you and goes through firmware, it goes through hardware, it goes through network communications, and it goes through application. And at each level, there are labs where you actually show how you can exploit each of those levels. And then the labs usually end up with, here's how you prevent these exploitations from happening. So you kind of dig into that, but also as part of that class, you actually do a vulnerability and risk assessment of the network, of a home automation network. And then there's a security game, which I'm really excited to get trying. We haven't been able to do it because of the pandemic, but there's a security game where it actually sets up multiple Raspberry Pis, and the students do tons of pen testing against these Raspberry Pis in order to find little, like, I want to say Easter eggs, but little nuggets of information. And as they progress, right, you can scale that up and turn that into a game. You can always put Kali Linux on a Raspberry Pi, which we've done before. And I've actually had students test, web encryption and break web encryption and do man-in-the-middle attacks and things like that. Obviously on a controlled network with devices that we were 100%, we controlled them. There was no illegal activity going with that. But one of my big things about cybersecurity is it's really hard to defend if you don't know how to attack. So I need my students to learn how to attack, but we got to do it in a safe way. And Kali Linux in a lab on a Raspberry Pi against other Raspberry Pis or against laptops that we know what we've set up the Wi-Fi and things like that in a controlled environment allows us to get that kind of experience. You can also do network scanning, like you can set up Snort and a bunch of other things in stuff similar to say Wireshark and those kind of assessments using Raspberry Pis. There's also a product out there, software that you can download. It's called the Pineapple Pi, but it's a portable hacking station. It's meant to be a portable hacking station. So we always have the conversation, whereas if you're hacking your equipment, that's not a problem. If you hack somebody else's equipment, that's a felony. So we have to continually have that conversation. But because I do have a lab designed for this, they have lots of opportunities to play and hack against known entities that they are given permission to do that with. So again, I think that's just my take on it. I really think they need to learn how offense works in order to be a better defender. I think it's significantly harder to be a defender if you're in cybersecurity, right? Because in cybersecurity, I have to defend 1,000 different vulnerabilities, and as an offensive attacker, I just have to find the one that you didn't cover, right? So, anyways, we're gonna move on. Programming, right? So if you teach programming, this is a gobbledygook slide, but like look on the left, you can see all the different programming languages. I went out and found you can actually do COBOL and Fortran and all kinds of crazy stuff on a Raspberry Pi. There's lots of flexibility in the IDEs that you choose, so you're not kind of locked into a specific IDE. There's lots of options there. And then the one thing that the Pi gives you that say a PC doesn't give you is those general input-output pins. I can add a temperature sensor or a buzzer or a button or LEDs or some other thing, photoresistors, things like that. I can add those to the Raspberry Pi that I can't just plug one of those into a computer. It doesn't usually happen that way. So it gives me more flexibility in having my students kind of work through problems and deal with issues. So programming, lots of options. You can pretty much teach most every language. Again, remember, it's a Linux machine. So if you can program on Linux, you can do it on a Raspberry Pi, right? Also then machine learning, right? So AI and machine learning, I know we're pretty excited. We're starting up an AI program here soon. But on the Raspberry Pi, Google AI, there's a TensorFlow version that works on the Raspberry Pi. OpenCV has been on the Raspberry Pi for a long time. The very last one on the left-hand column there, PyTop, has worked with Microsoft to allow you to have, from a mobile standpoint or a distance learning standpoint, you can use Microsoft Teams to have students using .NET to program a PyTop robot that everybody, like you would have cameras on the robot, and everybody that's in the class can actually send code through Microsoft Teams to this robot to have it do optical recognition and movements and things like that. So it's pretty cool stuff. And I put robotics here on the AI side because we do a ton of robotics. This is kind of the extra thing that we like to do here, but I have my students participating in Pi Wars, which is an international competition where we go to England. We went to England for 3 years. And then this last year, we canceled the trip 2 weeks before the competition because of the pandemic. But and those events, there's always autonomous events. So I'm always programming my robot to work autonomously, or not me, my students are. I don't do a lick of the programming for that. I'll help them troubleshoot, but it's up to them. But you can use robotics to teach AI and to have the robot learn things and do things. We have another group of students working with RoboRave and NASA to do some optical recognition or pattern recognition and to be able to move around an environment without running into objects, but also recognize what the objects are at the same time. So if you're doing AI, there's lots of really cool things that you can do, and again, inexpensive. That's the big part for me. Like I can buy a lab of 30 of these for the cost of 2 laptops, and I can have a bunch of students working on a bunch of really cool things. I mentioned earlier, I do an IoT class. So if you do or want to get into IoT, we have it in 3 or 4 of our degree plans. And the reason we do is kind of that third bullet point there. We reinforce a ton of these sysadmin skills where we do there's a lot of teamwork in my particular class. There's a lot of presentations in my class. There's lots of planning and things like that. And I hate to say the word soft skills, right? But that side of the equation we put into this. But they learn some programming. I tell them you're not going to be excellent programmers when you're done, but you're going to be able to recognize what's going on and be able to modify it and adjust. And then creativity, again, going back to that do component. I really think it's important that students learn to be creative with IoT or with computing in general. It's not all about following instructions. And I'll leave this one here just really quickly. Like if you are teaching these things, there are places where Raspberry Pi is actually being used in industrial components. And you can see an example there of that. All right. So real quick at the very end, a reminder, like, why do we use the Raspberry Pi? Why do I like to use Raspberry Pi? I like to use it because it's low cost. It's flexible. I can do all kinds of crazy things with it. It's pretty inexpensive. It's small. It's pretty powerful for what it does. There's a humongous community. So if I'm ever stuck, I can always reach out and find some help. It's tactile because for me, it's all about the do. And honestly, it's just really fun to work with. It's fun to play. In fact, we started calling workshops play shops instead of workshops because that's essentially what we're doing. We're just playing the entire time. And we learn. That's what's neat. It becomes play, but when you learn and you're playing at the same time, I think that's a better combination, right? So I'm hoping that you saw something interesting today, that you can think of an assignment that maybe you can add something in. I know we kind of went through it pretty quickly, but that was the kind of the goals. I wanted you to kind of get an idea. There's just so many things that you can do. Check out the webpage. There's lots of good resources there for you. If you're interested in learning a little bit more about this, I do teach for the Western Academy. I said WOTC. I'm just going to go with WOTC, right? So it's a Cisco training academy, but we do have virtual workshops coming. So June 7th through the 11th, we're going to do specifically, it's 4.5 days. So, 3 hours in the morning, 3 hours in the afternoon, 4.5 days. We're going to go through the entire Network Plus curriculum stuff that I do. And then the second week, we're going to go through a lot of these. We're going to pick and choose, right, the most interesting of the projects and do that. I think those workshops are like $50 or something like that. They're not overly expensive. I also teach formal Cisco IoT instructor courses, and the next 3 that I'm teaching are there listed. I do workshops too, so if you want me to come out to your school or a group of schools, I'm more than happy to do that kind of thing. And I do speak, workshops like this and conferences. I do workshops at conferences. I was using the funnest thing for me to do is a workshop at a conference, right? So I'll bring my lab and we just play and build things. So if you're interested in any of those kind of things, reach out, let me know. I am available all over the place. So my email's here, website. If you go out to social media and search my IT instructor, you usually find me. But that's me. And lastly, I want to thank you for hanging out with me. And then I'm pretty sure there's probably some questions that I need to answer.
Yeah, so we're pretty much out of time. Thank you, Kerry. But there's one question. There's some sort of chat going on here. Someone had asked, can I use the Arduino IDE to program on the Pi? And there was some back and forth about that.
So the Arduino, you can install Arduino IDE on a Raspberry Pi, connect an Arduino to the Raspberry and program the Arduino, yes. We do that in class all the time. You do not use the Arduino to program the Raspberry though. It's a different type of unit, right? So the Arduino is a microcontroller and the Raspberry Pi is actually a system on a chip computer, right? It's actually got the processor, video, and memory, and runs an operating system, whereas the Arduino doesn't.
All right, well, if you didn't already, guys, please, if you would, click that link in the chat box for the survey. It's like 5 quick questions, just kind of tell us how this was, give us ideas for the next one of these. Thank you, Kerry, for your time. Thank you, everyone, for joining us. This was great, I think. We got a lot covered in 30 minutes. We will share the slides, and we're turning this into a YouTube clip. We'll send you the link for that. And I think we're good. Thank you so much, Kerry. It was great.